Okay, I think we may have a longer lecture, so go fast. Okay, we'll start. Please. So, we started chapter 4, data mining. Okay. Now, this chapter is very important because of its application these days, and also your project that you will start, inshallah, is based on data mining. Okay. So, what we will be discussing, we already started it last time, so I'll very quickly refresh ourselves with, in terms of what we discussed last time. Okay. But please listen to it carefully, because what inshallah we'll be discussing today is important for doing not only your project, but data mining is a hot field. But I must give you a word of caution. Data mining cannot be covered in one or two or three classes. So you must understand the idea here. The idea is not to make you very good in data mining, but make very good use of time to give you enough that you can perform data mining without going into technical details. Data mining can get very technical in the sense that I can develop a model and run, but the quality and reliability of that model, to ensure that you need to have a good technical understanding of what is going on behind, inside the model, right? You understand what I'm saying? So we are skipping that, understanding the math and the technical parts of those models. But the point here is that you need to understand what data mining can do. Without, of course, we're skipping the part that it cannot be directly taken and implemented in a company. But still we are doing end-to-end, meaning that starting from there, developing a model and solving the problem, and skipping in between some technically complicated parts. But you will still understand what data mining can do. Okay. So what will happen next? The thing is that, for example, when you go to MIS 502 decision support systems, only one topic within all this data mining called clustering. It will take around half a semester just to discuss clustering, right? So just to give you an idea that it takes much longer to really get hold of the idea fully on when you technically feel confident in terms of whatever you're doing is correct. Okay. So data mining, if very quickly to recall what data mining is, and this is basically from our last lecture. Do you want to close the light?
Yeah.
Okay, so data mining is a non-trivial process of identifying valid, novel, potentially useful, and ultimately understandable patterns in the data. So the idea, if you remember, was that, and even if you go back to the start of the course, companies are collecting a lot of data these days, and you want to use this data for your business purposes, right? So this data is carrying a lot of information, hidden knowledge that you want to understand and learn. And that hidden knowledge is, we refer to it in a general terms as patterns. So for example, if you're selling products and you're storing your sales transaction data, it should tell you something about which product is more popular in which season, which the demand of which product is more and which product is less, right? And you can use all that information in making good business decisions, right? So those hidden things, we call them patterns. Normally we call them non-trivial simply because many of those patterns are not obvious. So you have to dig deep to find out, use some advanced maths, use some powerful techniques to discover those. Okay. So if we know that fact, we said that this is like the bigger picture. You need these because it's a data-driven technique. So you need, without data, there is no data mining, right? So it's a data-driven technique, meaning that sometimes you use your experience, right? That by my experience I can tell you this, but here we are saying that data is telling me that. Okay. And two main chunks are there: statistics and what is called artificial intelligence techniques. Data mining, so we make use of all these three things to find out. So one of the things that we discussed last time is that because it's data driven, so data is the most critical ingredient. No data, no data mining, right? It is as simple as that. So it is that. Other than that, source of data, we have been discussing this not just in this course, but databases, DBMS1, how to collect data, organize data, and all those things. DM environment, just the software. It could be web based, it could be like Orange. Have you seen my message about Orange, installing Orange?
Yes.
It's just a desktop application, right? It could be client server based and whatever. So the data mining platforms can be of different. They come in different ways. Soft, unstructured, various forms of data are there. The example that I will be discussing, some of it will be discussed in this chapter. Some of them, the example that I'm going to share with you in Orange next class, actually belongs to another chapter. So what you see here is data can be of different shapes and types. It could be categorical data. Categorical data meaning that your gender, male, female is a category, right? Or it could be customer type, young adults and senior people and so on. So categorical data or numerical data means sales data, how many items you have sold, numbers. But a third one is missing, which is part of another chapter, but inshallah we'll still be discussing it in Orange example, and that is called text data. Customer reviews, comments, tweets, feedbacks, right? So that is still a data that we would like to mine to find pattern. For example, in Orange, one of the examples I showed you is called sentiment analysis, meaning that when you see customer comments about a restaurant, I think you can sense some negative comments and some positive comments, right?
Yes.
So you can see, maybe your company would like to see after making all those changes, is the sentiment changed? Are we getting more positive comments? Or are we still getting more negative comments like that, right? So text, mining the text data. So different kinds of data, that is the point. Then when we say patterns, and extracting patterns is basically why we are using the term mining, data mining, where you mine or you extract patterns, right? But last time we defined what pattern can mean, right? Can mean means it's not just limited to this, but it can be, at least it can give you an idea of what pattern means. It can mean relationships. For example, between products in your trolley. If you buy dairy products, you tend to buy vegetables as well, because at that time you go to grocery store and you're buying things to eat, right? So you always see a person buying maybe yogurt is like buying cucumber as well.
Buying burger and fries with it.
Burgers and fries. Association.
You mean frozen one?
Whatever, I'm just trying to say there are relationships that maybe you apparently don't see, right? Like for example, when you buy a burger, it's highly likely that you will be buying the fries, right?
The cheese also.
Right. So it means, so you can create a lot of so association is a kind of a pattern. Finding those associations, right? Then clusters is another kind of a pattern. I have a lot of customers, but I see that I can find groups of customers that behave in a particular way.
Like the vegan one?
Maybe, right? Or you go to, there's a student she's doing research in price setting for cheese products.
Mm-hmm.
Because cheese is very sensitive to price. If you go to fresh cheese, you can see price changing quite frequently, right? And some of those cheeses are very expensive, hundreds of riyals even, right? And the price is very sensitive to demand. But there in her research, she found that not all customers are behaving the same way. There are customers who don't care about price. They are like, like rich people, even it's like 100 reals, more than 900, they say, they don't even look at the price, right? But then there are people who even the feta cheese, the very low cost cheese, even then they look for promotions and all those things, right? So what she did at that time was she was trying to find the relationship between price and demand, but it was a big problem for her because there wasn't any relationship coming out. So what she first did was to separate customers, and she found 7 different kinds of customer groups in her data, and then within each group, then she's now developing models, right? But what she used was groupings.
What about the prediction?
Prediction is like you have for example, oil price
Okay.
or stock price, right?
Okay.
You see your history, and you're trying to,
Okay.
based on that historical
Okay.
pattern, you're trying to predict what can happen.
Okay.
Is stock price going to go up or go down, and how much going up or going down, right? Prediction. So it is like historical patterns, and this is basically time series predictions. It is almost related. Then 2 key terms that
This is sequential, the same as prediction.
no, prediction sequential can be prediction if the price example I gave you.
Mm-hmm.
You're looking at your own historical price to predict future.
Mm-hmm.
That particular kind of a prediction is called time series or sequential.
Mm-hmm.
But if this prediction is based on other factors like ice cream sales based on temperature,
Temperature, right? Yeah.
that's not based on
Sequential,
yesterday.
yeah.
It is based on temperature.
Yes, right.
Like special events, like for example, Ramadan.
Yeah, so events, right? Or different attributes. So if if the prediction is based on so many factors, then prediction based on factors. This based on your own historical changes. Now, two things we talked about last time. So just to refresh yourself about these 2 terms: supervised and unsupervised learning. In machine learning, there are 2 things. One, you guide your machine learning algorithm on certain basis, and then you just let machine learning say, I don't have any idea about my data, tell me what you can see. 2 examples, classical example always is given to you is between what is called classification and then clustering to compare unsupervised and supervised. So if I give you the data and I'm running a retail store and say, tell me about my customers, I have no idea. So the algorithm will see, I can see that there are at least 3 different kinds of behaviors. I can see 3 groups, right? Now, there was no basis of that. Just the data itself was looked at by the algorithm, and the algorithm see that I can see that there are 3 groups. That's unsupervised. Okay, but if I see that, I tell you that there are 3 groups, and each group has these attributes. For example, group number 1, I see my customers are young, ages between, let's say, 15 to 25. Their income range is so and so, their gender is so and so, and I'm going to then calling it like young adults. Another group, middle-aged people, higher income, right? And their buying pattern is different. They tend to don't care about promotions. This one care a lot about promotions, right? Now, in classification, a person enters the room. Now, I say, can you please classify this person? Is that person belongs to this group or this group or this group? You understand how it works? You see, a lot of guidance is there. Groups are already formed. Their attributes are already defined, right? And then you are using it for example, for prediction. So this is supervised. You're giving a lot more information. You're guiding your algorithm with so many details. Okay. So Time series forecasting I already mentioned, if you're just looking at your own historical prices and so on. We did talk about hypothesis driven and discovery data driven. Hypothesis meaning that it's basically supervised, you already have an understanding of whatever is going on, and discovery driven is like clustering. We did talk about a lot of examples there of what can be done. Forecast, for example, you can use it for prediction, forecasting, assessing, identifying. So please, have a look at it. This is basically from the last time. I really wanted to start here. Now, what I'm going to discuss now is the roadmap for your project as well. So please, you have to listen to it carefully, okay? This is end-to-end data mining, where you start and where you end, and in between whatever task you do, minus the technical details, the mathematical details, okay? Those mathematical details will hide it under Orange, behind Orange. Orange is an extremely easy to use software. So instead of knowing the model, the math behind k-means, we'll just drop k-means and ask it to do k-means, right? Without going into too much details of what is the Euclidean distance and rectilinear distances and all those things, okay? But you'll get the results, okay? But you'll get the overall experience of how the whole data mining exercise is done. So overall, bigger picture is important at the moment. So there are multiple approaches people use. For example, one is called CRISP DM approach or SEMA approach. So it's like the whole story, where you start and where you end. CRISP, by the way, is mostly used. You can use your own way of doing data mining, and I'll talk about that. You'll be able to understand more when we start looking at this particular methodology, okay? So this is CRISP approach, CRISP DM approach. Data mining is done not just for fun, it is done for a purpose. You need a problem to solve. You have a business problem and you want to solve it. I told you this example of this lady trying to finding relationship between price and demand, and it was very inaccurate results were coming. So she had this thing that there can be different kinds of customers. So she wanted to find out if there are any different kinds of customer groups and how many of them are there. So that's what you call a business problem. So whenever you need to have a business problem that you're trying to solve, another business problem. I wanted to invest in stock. I have those historical stock prices, right? I want to understand those stock prices so that I can predict the future stock prices. Business problem. You all understand business problems. So when you're going to be doing a project, you should be solving a real business problem that you're facing for a company, okay? And I think what I send you as a zipped file, 5, 6, 7 examples are all, I will walk you through this, okay? I'll tell you what the business problem is, then what data we need to actually solve this problem. For example, I need to predict stock prices, so what do I need? I need previous historical stock prices, right? You understand what I'm saying? Mm-hmm. I need to predict customer groups, so I need customer attributes and all the data that I need, right? So it starts with business understanding, what business context or problem you need to solve. Then according to it, I need to know what data I need to gather. So for customer data, stock prices are meaningless, right? So I need to gather the information that I need to solve this problem, data understanding. And then by first of all finding out what I need, then I'll prepare my data, and I'll talk more about it. Data preparation means gathering and cleaning and all the things that we have been talking about. And then this will be our orange part. We know that, but not just orange. First we have to select what exactly are we doing. Are we doing something called clustering? Are we doing something called prediction or association and text mining, sentiment analysis, or whatever our problem. And then based on what we have to do, we will do an orange code, okay? And then but this is not enough. In reality, you always have to do what is called testing and evaluation. So what does testing and evaluation means? Model always try to capture whatever is going on in the data. But the data will always have something what you call noise, distractors. So for example, if you see the price like this, what do you see?
Increasing.
Fluctuation.
Now what your mind just did was to ignore when I was doing this. And your mind trying to pick up this part. Do you see that? Nobody mentioned about this
The
up
fluctuation.
and down.
It's about the short term and the long term. So in the long term, it's increasing. In the short term, it's up and down.
Up and down, right? But when I gave you this picture, what your mind tried to did for this whole part that I gave you, you tried to pick a pattern, right? Something that you can explain. Now even when I do it like this, with the change, can you see the wave? Season, maybe it could be seasonal change, right? So something that you can explain, if you cannot explain something is going on, normally we call it a noise. Unexplainable things. Explainable movements are called noises. Now, what happens in these models is that some of those models are extremely sophisticated, and they not only capture patterns, but they can even fit noise. Able to capture, assuming that even noise has a pattern in it. Okay, but there is a problem with that. So we will talk more about this, but let me just show you something. Let me tell you, one of the problems that is faced, because I need to show you why it is this particular discussion is important for you to know. Okay, let me show you this. Can you see this one?
Nothing shows in.
Nothing show. Oh, what happened? What happened? Can you see it now?
Yes.
Now this is your data, not the lines. Lines is like what model is trying to fit. Okay, you can see that it's going like this, right?
Mm-hmm.
But there are some up and downs. By the way, there is something called error.
Margin error.
No, error, just error. Error is the difference between your predicted value and the actual value. So this is the actual value, this is the actual value, and this is your model predicted. So the difference is
gap.
the gap is the error. You understand that? Now you see 3 different fits. This is called a linear fit. You're trying to fit a line, a regression. Okay. Now errors, you can see that errors are more as compared to this fit, right? But still it makes sense. Do you see that it's like a curve? Data is going like this. So which model is better? This one, right?
The last one.
This is called underfit, meaning that you can have a model that can better fit into the data with less error. Better fit means your error is going down. Total error, net error, average error. There are different kinds of errors that we talk about, right? So as compared to this model has smaller error. You can see the errors are small here, the error, because of that the errors are big. Okay. What about this one? This one seems to have even less error.
More accurate.
But we don't use this one. We call this overfit. What does that mean?
Maybe the prediction over than the actual.
I'll tell you something. Here we are trying to fit each point into the model. But if you actually see the use of the model, the use of the model comes in future.
So trying to be perfect.
No, just hear out the whole thing, then you'll understand. Okay. So, for example, if you're trying to see the stock, this is your demand. You're trying to see what can happen next. Okay. So when you use the new input variables, I'll tell you what happens in these cases. Whatever be the average error coming out here is going to be the average error coming out when you're going to actually use it with a different data set. Data set means new scenarios.
Example.
New scenario meaning that I have my customer data and I expect this demand, but then new customers coming.
Mm-hmm.
The errors will in the one in the middle will still remain the same.
Okay.
But when you're going to use this one, if the error here was accuracy was 90%, 10% error, so 10% error, 90%. But in this case, the accuracy was 98%, but when you actually use it, the accuracy goes down to 50%.
Oh, okay.
Oh,
Because it's exactly this data is trying to fit. When the new situation comes in, there will be differences, right?
okay.
But the overall pattern will hold.
So the balance takes the average.
So here you're trying to capture the overall pattern, not the noise.
Yeah, I got
Here it's trying to not just capture the pattern but the noise itself. But the noise does not stay the same.
you. It's like an outlier. So
All those random things that you cannot explain. So the randomness will continue in a different way.
So
So the error, for example, here maybe a point comes here, but it says go up.
you can't be perfect, but just be balanced.
Balance is because you can see the explainability, it goes up,
Mm-hmm.
right? Here it just tries to capture each point. So
And that's almost impossible.
Of course, 100%. If something is explainable 100%, there is no randomness. You don't need data mining even.
Okay.
It's deterministic systems. You're talking about systems with randomness, with unexplainable things, right?
Mm-hmm.
That's why you're looking for mining and trying to pick things up. Okay, if you're running a Coke factory,
Mm-hmm.
Producing bottles,
Okay.
it runs on a machine. You know exactly how it works.
Yeah, some are defects.
No. Forget about defects. In terms of running, next bottle comes in, it goes on a machine with a perfect timing.
Yeah.
There's nothing to predict,
Yes.
right? So I mean, we are not talking about that. Okay, so that is why we do a lot of testing and evaluation, and how do we do that? And we are going to talk more about that in a second. But keep that in mind. Keep this part in mind because we'll come back to it. This is the last part is very critical. We may not, one of the examples that I'm going to show you in orange is actually to show you this part, how you can do that in orange. Okay, so and I'll come back to it in a second. Okay, so these steps: know your problem, prepare your data, know what data you need, prepare it. This is something we will discuss more on it. Build your model, test and evaluate, and then use. Without testing, no using. Okay. So when it comes to data preparation, what do we mean by that? We have to collect the data from different sources. We may have to collect that. We may have to process the data in terms of cleaning, removing the missing values, eliminating inconsistencies, meaning that some data is in dollars, some are in reals, right? So some in kg, some are in pounds, right? So we just have to make sure the data is consistent. This is the technical part that I said we cannot go into too much detail in this course.
About SQL, this is all
No,
about
this is not SQL.
normalized data and all this stuff.
No, this is another kind of a normalization. I'll quickly mention it to you, but I'll come back to it. Okay. In k-mean clustering, for example, in MIS 502, you'll see that there are grouping is based on product attributes, different attributes, weight, height, colors, and many other things, right? Now, one of your columns is in thousands. The numbers are coming in thousands, 2,000, 3,000. Another attribute is coming in single digit, like 1, 2, 5, 7, 9. One of the technical things that we will teach you there is that the bigger numbers dominate the clustering process, meaning that those numbers will dominate the formation of groups. We don't want that. We want equal weightage of all attributes. So we do things like data normalization, meaning that we'll put scale all data to 0 on a scale of 1 to 100, 1 to 100, 1 to 100. Scale them. That's called normalization. But it's a technical thing, right? So those technical things these kinds of technical things I'm saying that we might be skipping here, okay? Because there is a limit to how much we can do for now. Another important thing, there are 5 attributes we are looking at, but 2 attributes have one-to-one relationship. There is no difference. They are just the 2 sides of the same coin. Meaning that if they have exactly the same relationship with the output. If X goes up, the Y goes up, right? So you have let's say Z is your output variable, so X and Y. The amount of change in Z that happens with X is exactly the change that happens with Y. You understand what I'm saying? So if X and Y goes up by the same amount, exactly the same impact happens on Z. So basically, some of the variables are so similar that there is no point keeping those 2 variables separately in your model. You say just keep one. Why are you having two exactly similar things in your model and overcomplicating the model? This is basically called feature selection, etc. Again, it's a technical thing. We are not going too much into it. So how many attributes you'll keep in your model? So you get the data with 10 attributes. There is a method to say, look, 2 of them are useless, 2 of them are similar, so just keep like, let's say 3 of them. Okay? So again, some technical details, but we call them data reduction. Means use what you really need. Don't use unnecessary things in simple language. Okay? Use anything that you use unnecessarily, it will going to be impacting the quality of your model. Quality in terms of accuracy and so on. Okay. Now, just like the last one was crisp, this whole approach was crisp. Another approach that people use is called SEMA. Still telling you the same thing. You'll still see the same thing. You see, assess, evaluate test the model, develop the model. But this part is something that I like, additionally mentioned, which was not there in CRISP. And I feel that it has to be part of, so CRISP is of course better, but if you can add explore, then it's even better. Explore meaning what? Before, it seems like in CRISP, you take the data, you put it into the model and say, khalas, you trust whatever comes out. You're leaving your judgment out. You are there for a purpose. You are humans. You have something in there.
Explore means search, for example.
No, I'm going to give you an example. Okay. In exploration, you don't use sophisticated models. You actually use simple techniques like plots, like simple statistics, like means and variances, to get an idea of what you can expect. Okay. So I'll give you an example. One of our MSB, a Master of Science in Business Analytics ladies, these days she works in Johns Hopkins Hospital, and she's working on developing a hazardous waste prediction model. So these hospitals produce a lot of, toxic waste and hazardous waste and so on. And the hospital needs to plan their resources by predicting how much waste they are producing. So they need to see, today if I have so many patients on bed, so many operations going on, so how much waste am I going to be producing? Because that waste cannot be just like a good house garbage. You have to plan and then, plan accordingly, right? So she's working on that. And when she tried to fit a prediction model, it was giving very poor accuracy. So we sat together and said, did you try to just plot and see, the data? you know what the data looks like. She said, sorry. I said, come on, you're using neural networks and random forests and did not even plot and see how the data looks like. So she plotted. And you know how the data looked like? The data was like this, drop, and then going up.
Mm-hmm.
I say, what is this thing? What is this thing? And then I say, look at the dates. This was pre-COVID. COVID, no hospital, you know, everything was closed and everything. And then there is a consistent rise. I said, what exactly are you trying to capture? Even pre-COVID, during COVID, I mean, you are actually trying to capture whatever is going on after COVID. Because it was going like this, upward trend. And I said, now cut the data. You don't need the data before that point. Cut and then fit.
That's a reduction.
And that's data reduction. Also meaning that unnecessary, it is actually hurting her model because trying to fit everything that is going on, right? So we cut that part, and guess what? The level of predict accuracy went up from, let's say, 50 something percent to 96, 97%, something like that. Very accurate. But just by doing data exploration. Okay, so you understand the overall thing that is going on. So you know your problem, you get the data, you try to explore first, you get a sense of what you're looking at, right? And then you try to fit the model, and so that exploration part is important. Okay. Now let's look at, I'm going to go a little quicker here. These are just some possible data mining applications that you can face in your business situations. And then, you know, you need to know their names, because when you face a problem, you know, it's a classification problem. It's a clustering problem. It's a prediction problem. You understand what I'm saying? So just without going into too much technical details, I'm going to talk about that, but I think, you know, let me just go to this slide and then come back. Okay. This is explained in the classification context, but you remember I talked about overfitting and underfitting. I said that you use on a new data to see whether it's giving you the same error as your data that you use to develop the model, right? So this approach is very, very important for any data mining application. So normally, for example, the cheese example I think I gave you now, she has 30,000 data points, 30,000 individual sales. So how can we do testing on it? So just you take the actual data, because you cannot wait for future 2 years to collect more data to see the performance of the model. So what we do in normal circumstances, we take the same data and divide. Normally 70%, 30%, 80%, 20%, something like this. And we use this data to train the model, to fit the model. And then use the remaining data that was not exposed to the model to test and validate. See if I bring this new data, is it going to give the same performance as the training data or not? And the rule is very simple, I told you. If the error here and here is the same, approximately, you have a very good fit. If error is high, accuracy is high, but it drops here, what is the problem you're facing? What is the problem you're facing? I showed you this example. The problem you are facing is, where is my browser? Sorry. You're facing this problem. And what do you call this one? You understand? If my training data is giving me high accuracy, but my test data is giving me low accuracy, it means that what I have done is overkilled the thing, overfit it. Okay, and there are ways to address that problem. Not over. How can I not overfit and do it more accurate? Okay, and then of course there is like low accuracy here, meaning that it's underfit. Right? You try to fit as much as possible. Now let's just go back and let's look at few possible things that you can do. One of the things you can do is classification. I already told you what classification is, right? You have created classes, and when a new data point comes in, you're trying to predict that this data point belongs to which class. Okay? So for the first you have to train your model about what a class means. So when I say young adults, you have to train your model what this class means.
Or what segment?
So it means that we will have an Excel table in which you have attributes, and then you have an output called class. So when you say young adults, in attributes age you'll see 15 years, 19 years, 22 years, 16 years, right? You understand that? And then income, accordingly and so on. So the model will learn, okay, whenever I see young adults, I see these attributes, these ages, these salary brackets, right? And so on. And then when I see professionals, I see 30s, ages between 30s and early 40s, maybe in these incomes and so on, right? You understand what I'm saying? After training, then you can use, a new point comes in, then you can use that to classify. So it is a supervised learning. The output variable is your class. You wanted to predict a class, right? So output variable must be there. Supervised learning always have an output, okay? And you guide them. What is important is your prediction accuracy, meaning that whenever a new person comes in and I need to classify in one of the categories what is the hit rate. Hit rate means that am I able to classify that person correctly or not? With what accuracy? Is it like 90% accuracy, 95% accuracy, 50% accuracy? As you can imagine, the higher the hit rate, the higher the accuracy, the better. Okay? We'll talk a little bit about accuracy in a bit. Other things, speed has become less of an issue these days with the speed of computers and good quality software. But it used to be 15-20 years back. It used to be a big problem because model will take several days even to train. Okay, scalability and interpretability. Scale meaning that if my problem becomes bigger, can my model handle it? Right. So you have to retrain and everything. Interpretability meaning that the results, do they make sense? Explainability is also the same thing. So let's just talk about accuracy. Let's just define accuracy a little bit more in classification. Okay. So how do we check, first of all, accuracy? We need to have a data for which we know the answer already. Okay. So in my test set, I know, for example, if I have people like within you, I know it's young adults. Then I have maybe like faculty, like maybe older ages people, right? I know the answer already. So, and then I give it to the model. I give you just your attribute. I did not tell you that you're a young adult. I say this age, this income, and so on. And see what the model tells me. If the model classifies you as young adult and the answer was yes, for me, young adult, we call it positive, positive. True class, young adult, yes. Predicted, young adult, yes. We call it what? True. Everybody understand what true positive is? The answer was supposed to be yes, and yes, you belong to young adult, and the model also said yes, you belong to young adult. But if you belong to young adults, but the model says no, doesn't look like young adults, other class. A misclassification, not classification, misclassification, wrong classification. We call that what?
False negative.
False negative.
Can you give an example?
You are supposed to be young adults, right? Model says that no, it doesn't look like young adult.
Oh, okay.
Based on your characteristics, say your age, and so misclassification. Another one. Maybe a senior person comes in and you should say no, not a young adult. But the model called it a young adult.
But by how the way he looks.
There are so many attributes that you're using to make this decision. I told you age, income, many inputs are used. Okay, so based on that, it's called false positive, false negative, false positive. Should have said no, but should have said no, but called it positive. When the model should say negative and called it negative, correctly says no, not young adult, and it was not adult, so it is called true negative. Now, what is the accuracy? Which ones are correct? These two.
Both, yeah.
These ones are wrongly classified.
Mm-hmm.
And you count. First person comes in, we see how many true positives comes in, how many true negatives comes in, how many false negative, how many false positives. Yes.
But the false positive, it's correct, right?
No. See here. False positive is when the model should have said no, it called it yes. Meaning that,
Oh, okay.
you understand that?
Yeah.
It should have said no, it does not belong to that class, but said yes, it belongs to this class. So you have to see how many times it was correct over all counts. So you tested 20 people. So this is 20, right? Some of them were correctly identified as young adults and some of them correctly identified as not young adults. So you see, if this number is high, of course, that's what you want. The higher it gets close to 100%, the better. Okay? Now, there's something called true positive rate. Now, you can look at overall, you can look at just this line, like here, like here, like here, like here. Each one we are giving it a name. If you're just looking at this column, okay? Just see if you're looking at this column, TPFN. TP over, we call them true positive rate. How many true positives, when actually it was positive, how many times it correctly identified it as positive? You understand what does this say? How many times it correctly identified it as positive when it was positive? And the other one, you can see how many times it correctly said no when it had to say no. And this is called
Negative rate.
true negative.
Doctor, do we have an example to see how
You can see, when we will do orange, we have a real data and we can see more. Okay.
No, how to use the equation in real examples. That's what I mean.
I'll bring an example.
Yeah.
You can solve just this part. This is the only part, numerical part. I'll try to bring something. Okay.
Mm-hmm.
True negative rate and precision is what? Can you see TP over? This is precision. You just call this precision. It was predicted class. How many times it correctly predicted, positive, and then recall is just the same thing.
Mm-hmm.
So accuracy. Okay.
Could you go back to the recall, doctor?
Yeah.
The recall?
Recall is the same. Can you see it's the same thing with just another name for it?
Okay.
Okay. Now, you remember what I just said here. Normally you cannot wait in the future to test and see whether you have overfitted or underfitted, right?
Mm-hmm.
So what do you do? What did I tell you? You take your data and you split. And the example I'm going to show you next class, please bring your laptops and Orange installed. One of the things what I did, I took the data, I randomly split 20% of the data, saved it in a separate Excel file, right? And I used the 80% data to train and that separate 20% data to test and compare.
Mm-hmm.
Okay? And then you can see here whether it's an overfit or underfit or not. You can compare the accuracy between the two. Now, this is certainly a way to bring confidence into your model. If you want more confidence in your model, we can even do it more conservatively by using an approach called K-fold cross-validation model. How many data sets are we using for testing? We just use one. We just split and took one. Right? Do you understand that? I took my data and I took 30% for testing. Okay, but this is one data set I took out. I just may happen to be an extremely lucky person that day that the data that I took out fitted better than if I just took another one and another one and another one. You understand what I'm saying?
Yes.
Because still it's a random chance. So K-fold basically says that don't use one test set. You split not just in between two, you split K. Meaning that you don't rely on one test set, you use more than one. Right? So that it is again a different one, a different one, a different one. If all of them are giving the same accuracy, then your confidence will certainly go up on your model. Okay? But it is still a very common practice that it is still quite reasonably defend yourself if you use at least one.
And if
We are all using one these days. Very rare to use multiple ones.
if
If there is a huge variation between the tests, what should I do?
It means that, look, train set says accuracy 90%. First test set says, let's say,
20% for example.
yeah, one of them gives you very low. It means that something is wrong somewhere.
because if the variation too close to each other, what does mean?
Accuracy?
Yeah.
It means that you have developed a good model. But normally still if you use reasonably large sample, one sample, chances are you're safe. Because if you choose a very small sample, then huge variations can occur. So normally in practice what we do, because we have limited data, so we make sure that we don't take too small a sample to test. Because if I'm just relying, for example, on one person, you can imagine every next person gives me a completely different, 100% failure, 100% accurate, right? Can you see that? But if I'm using in classification 10 people, it balances things out, right? It averages things out, so you normally get good performance. Now, one of the things people use to compare different models is to compare their false positive and true positive. You want false positive or true positive? Just go back. See what we said. When you have to say true, it did say true, positive. True, positive. False, positive. You don't want that to occur, right? So in classification, for example, you're trying different models, different algorithms. Which one seems to be giving you more true positives? A, B or C?
C.
Are you sure?
A.
True positive is on what axis?
It's A because C is 50-50.
Yeah, so you can see that this is true positive, right?
Okay.
The more you rise on this axis, the more you're
I just
correctly predicting.
maybe the balanced one I thought.
No. This is, imagine it's a test, right? But overall it is giving you better. Balancing is separate. Balancing is about comparing. It does not mean that you don't want high accuracy. Khalas, if I need 99% accuracy, 99.99% accuracy in my training, and I'm getting 99.99% accuracy in my test as well, khalas, that's the ideal thing. I'm not saying you lower your accuracy just for the sake of it. I'm saying that both have to be the same. If this is high but this is low, it's a problem. But if both are going up, you can go as high as possible, right? So you don't want underfit as well. Okay. Now classification. You all now understand what classification is.
Yes.
Now we never mentioned that classification is a problem, not an algorithm. not an approach. Classification simply means create classes and predict. But how is the question? Means you have to go to data mining, and for each problem there are apparently several algorithms that you can use. For example, in classification you can use something called decision tree analysis, or you can use neural networks, or you can use something called support vector machine, or you can use case-based reasoning, Bayesian classification, genetic algorithms, rough set, fuzzy set, and the list keeps going. Which one is the best? There is no best. There's in data mining there's something called no free lunch theorem. No free lunch theorem, meaning that you cannot tell which of the algorithm will work better for you. So what do you do? What can you do? Because you cannot tell which algorithm in your case will work better. So what do you do? The only thing you can do is try multiple ones and see which model is working better for you. You remember ABC? This I showed you. So you have to try, for example, decision tree, and you have to try random forest, and you have to try support vector machine, right? And this is exactly what people do. And this is, for example, in this case, for example, here, if I can just quickly, she's using regression and support vector. Can you see here? Regression, support vector machine, artificial neural network, random forest, logistic regression, and then picking up the one that is giving you the best ones, the highest, right? So you cannot tell, you have to try. And the code I showed you, she wrote like 6 codes to compare different things to see. But the good part is the changes in codes are very small. You barely have to make a big difference in the code, just the model that you have to change. Okay. So everybody understand why we have so many algorithms? Because there is no one perfect algorithm. There is no one perfect algorithm that you can use. Okay. Decision tree. Let's just look at decision tree. For example, how decision tree works in classification. All of them, they work in a very different way, and that is why they produce different results. Decision tree is, have you studied decision tree in Math 308 or something?
Yes.
Quantitative methods. They may be using decision trees in a different context, but at least you can see those tree structures like this, with probabilities assigned and all those things, right? So it is coming from that concept. But let's look at an example. True and false positive examples can also become from this example, okay?
Mm-hmm.
So this is an example where you say you collected the data about whether a game of golf can have happened based on certain weather conditions. Historical data, professional golf going on. So people say if weather outlook said it's rainy, temperature is hot, humidity is high, there's no wind, it turned out that people decided not to play golf.
Yes.
Another one, it was rainy, hot, high humidity, but even windy, still people decided not to play golf. But when we say overcast, hot, high, no windy, people have played. So people collected, we collected a lot of data, whether people have decided to play golf or not, those, okay? So this is your class. So what classes do you have that you're trying to predict? Whether you play
Or not.
Based on these
Yeah.
attributes, these weather attributes. You understand that? So input, output. These are called predictors, and this is the target. Now, if you're using decision tree, the way they use is they say pick the one. There are few. I'm going to quickly explain. Create a root node and select the best splitting attribute, meaning that Splitting meaning that you have to split between play or not play. So pick the attribute that is most important seen by the algorithm. So what does that mean? Is this the one, or this the one, or this the one, or this is the one? Algorithm will see which of the attribute to the decision tree algorithm is most important in classifying yes or no. So call it at a root. So what did it pick? So what did it pick? Outlook, temperature, humidity, or windy? See here. You understand how it's working? Let me repeat. How many attributes or predictors do we have?
4.
4.
Mm-hmm.
The algorithm will identify which one of these is the most defining one.
The
More
t-
clearest one to identify.
Most likely.
Defining. No. You don't decide. The algorithm is deciding. But you understand the problem.
Yeah.
The
But,
algorithm has to pick which one is the most relevant one in deciding.
but most likely here, the weather, the temperature, I mean.
No, you're just thinking. You're just hoping. The
Yeah.
algorithm will find.
Okay.
But it turned out that the algorithm picked which one to be the most relevant one.
Mm-hmm.
Which one?
The outlook.
Outlook. So for decision algorithm, it thinks that outlook is the most important one. So what do you see under outlook? Sunny, overcast, or rainy.
Mm-hmm.
So these are the three things that under overcast that will define whether you're going to be playing or not playing.
Mm-hmm.
Second, then it picks the second important one related to here. That's how decision tree works.
Mm-hmm.
So when you see sunny, so it picks up all the sunny ones and then see if any other attribute in relation to that one is playing a part. So apparently, when there is sunny outlook, windy plays a part. False true. When there is no wind, you play. When there is wind, you don't play.
Mm-hmm.
Can you see how the more algorithm? So algorithm, this is the output of algorithm. I'm just interpreting its result.
Mm-hmm.
Then it says when it's overcast, yes, you play irrespective. Means there's clouds, there's no rain. Overcast is just when there's rain and humidity is high, it turn out the algorithm say people will not be playing. And then when there's normal humidity, people still play. So how does then classification works? How are you going to use this decision tree to do classification? Today, what's going on today?
Overcast.
Overcast. So what is your
Yes.
yes, you will play. You understand? So today is you classified as a day when you can play
Golf.
golf. You understand that?
Mm-hmm.
But this is decision tree. Completely different way of doing that using regression, there are many other techniques. Okay, but is this prediction accurate or not? You have to see how many true positives, and you can use the same measures that I showed. Okay, let me just go and the thing is that how that algorithm is picking up the top node and all those things. There are different technical. This is the part I'm skipping. There is something called Gini index and information gain and entropies. Just need to know the name, but this is the math behind it. So the math is we cannot go into the detail. Otherwise, we'll need like 2 classes just to explain those 2 measures. Okay, but you just need to know that there is like a mathematical approach behind all of them. Okay, and you will be able to learn it maybe in another course. Clustering. What was clustering? I gave you the example of clustering because it keeps coming back to us, right? Making groups, making segments within the data, unsupervised. There is no output. Why there is no output? Because you're creating the groups.
Mm-hmm.
Okay. So, and it's also called, by the way, segmentation. So how do you create? Where can you use clustering as a business application to identify natural groupings of customers? certain medical diagnostics, etc. If you see certain attributes together, it's a sign that there can be, a certain disease that can happen. So you can use clustering there. Okay. It is also used to support classification. Where did you get your classes when you don't know your classes? Normally what happens is that you use clustering to form groups, and then each group you label it and call it a class. Okay. I wish I could show you the example for that lady that I was mentioning about cheese. And based on the number of items sold and the age and the income, etc., we identified 7 groups, I told you. So those groups, we just know the characteristics, typical characteristics. So we gave it a name, young adults and professionals, and I think if at the end of the class, if I have time, I'll show you the output of that particular example, right? But it can be used in classification. Clustering can also be used in identifying outliers. We typically have this group and this group and this group, but there are some people who do not seem to belong to any group. Where is the application in such situations? One of the common one that people always give example is insurance fraud. When you have people coming and you have your behaviors, their application for saying that I have this insurance claim, okay? And you have so many attributes mentioned there. And you can see that based on the attribute, this person belongs to this category or that category or that category for insurance company. But there's someone who looks very odd, suspicious. Things are not adding up. Doesn't seem here and there and there. And you flag it up as a fraud. Not calling it a fraud, but suspicion, you raise suspicion flag, meaning that you are going to be very careful with that. Maybe there is a potential fraud going on. Maybe it's a genuine case. And again, we have actually a project going on here about fraud detection here in master's program. And she works in a insurance company, car insurance, very big insurance company, and she is also using real data to perform this fraud detection. Okay. Now, same problem as I said, classification is a problem, not an algorithm. So clustering is a problem. So how do you do clustering in terms of algorithm? In MIS 502, you learn k-means, k-medoids, hierarchical clustering, and many other clustering approaches. But there are more. Neural networks can be used, something called fuzzy logic, genetic algorithm, long list. Which one is the one that you would like to use? One answer is the same. You have to compare. Second answer is that there are certain techniques which are more suitable to do certain things. Like k-means, general grouping, but not good for outlier. People at least know that. For outlier detection, there's another algorithm called dbSCAN. So people use that. Okay. How do k-means particularly, what is that? Okay. One of the core concepts in clustering is similarity and dissimilarity. When you group people, what is the idea behind it? How do you group? You group people, say, because they look similar. Do you agree? Grouping, when you say there is a group,
They have common characteristics.
they have to have certain common characteristics, right? When I say young adults and professionals, right? What is the common characteristics? Age, similar ages, right? Similar income brackets, right? There has to be what you call similarity. And why you say this is different and you are different? Because there is a dissimilarity between this group and this group. Are you all with me? So similarity and dissimilarity, how do you measure similarity and dissimilarity? We use what is called distance. Distance does not mean distance in kilometers and meters only. Distance in terms of age, distance in terms of wages and whatever, right? Different, multiple characteristics even. Okay? So, just remember this part. Distance is a very important aspect. So, when you say clustering, this group seems to be close to each other. small distances, right? So seems to be like a group. Maybe another group here, right? You know, this one is a little bit challenging data, but maybe it says, the algorithm says it can see 3 groups, right? But you can see that mostly they are close. Each group is like close to each other. Now to define the group, we always need to define what is called a center. What is called a center? Randomly set. So even before that, we need to first tell, it's actually a wrongly put word. The algorithm needs to know how many clusters to test. So when you say how many clusters to test, the algorithm needs to first assume that let's try 2 clusters, let's try 3 clusters, let's try 4 clusters, and then there is a way to see which number of clusters is giving you better results. Okay, but based on that, what it does in k-means algorithm, particularly k-means, you know that you're testing out 2 or 3 or 4, and then a cluster is represented by a center always. A grouping is always represented by a center. What does that mean? If 5 people are in a group, one of you is the most representative of that group, meaning in terms of age, in terms of wages and so on. You know, that is representing that, right? So if you have a group that has an age between 15 and 25, maybe a person age 20 is like in the middle, right? Which is like representing a typical age in this whole group, right? So you start by, I'm not going to spend too much time here because MIS 502 will spend like half a semester on it, okay? So, but the idea here is that you start by defining centers, and then you see the distance. So if I'm going to use this point is close to this center or this center or this center or which center? You can see that it's close to this center. So you say this point belongs to this cluster. What about this one? You say it belongs to this one, right? Now, the initial centers are randomly assigned anywhere. So maybe these are not the best centers. So what you do, you assign and you iteratively improve the center. You improve the algorithm, the design of algorithm is like that. The center location is improved, and you'll eventually have that. How much time do we have?
Less than
10 minutes.
Yeah.
So let me just quickly talk about a few things. Association rules. We already talked about association rules in the beginning, right? When we want to see market basket analysis, we want to see relationship between products. If you're facing that problem, then you can use association. For example, these are like 5 people who bought products. Milk bread eggs, milk cola, diaper beer. Which one seems to be always coming together? The red one we are trying to show. Diapers and
the beer.
beer. Just an example used. Don't think that it might be actually true or not. But you know, it's a very common example that people give in the classrooms. But trying to show why it's given, because normally you don't think that there is a relationship between diapers and beers, right? But so it can reveal you those relationships which you might not be able to see. Okay, but the thing is that how do association rule works? It's an unsupervised learning. It just creates those rules. So it shows all those relationships. So let me read this, and then I'll just stop here after this. Customers who bought laptop computers and a virus protection software also bought extended warranty. It turned out in market basket analysis. So if you are buying just laptop, you go to Jareer or Extra. It's fine. You know, you buy and you take the warranty and leave. But if Jareer and Extra happen to see that if you're buying laptop with an antivirus software, it's highly likely that you will buy extended warranty, 2-3 years. So this is a very useful information. Why? Because you can use this in cross-marketing, cross-selling. Meaning, if you have bought a laptop with an antivirus and you come to pay, I know from my knowledge that whoever is buying laptop with an antivirus is highly likely to, I'm going to say, would you like to buy extended warranty? I'm trying to sell because I know by pattern that people in their mindset, whoever is buying laptop with an antivirus, they are buying extended warranty as well, right? You understand? So cross selling, cross marketing, lots of advantages in that. So how do association works? You say the relationship X driving Y, and then you need these two very important numbers to see to use to understand your business benefit of it. So what is X and what is Y? Let me use this example again. So X is customers who brought laptop and an antivirus. This is X. Also got extended warranty is your Y, right? So this is something you see and what it is driving, Y. So what is S? Support and confidence. These two things are again more important things to know in association rule. So what is S? How often a given rule appears? How often in your store do you see people buying laptop and an antivirus together? This is support. If this number is low, it means that it doesn't happen too many times. Not a very important thing for you, right? 5% of the time, okay, no, it happens. But if it is happening 80% of the time, something very important, recurring, very important for your business, right? Confidence. How many times this rule turns out to be true during whenever it appears? Meaning that whenever a person buys a laptop and an antivirus, also agrees to buy an extended warranty, right? So how do you interpret this rule? How do you interpret this business situation? Laptop antivirus is your X, driving extended warranty. So what is this? What does this number tell you? 30%.
30% for the X and the
No, no,
extended.
It's a random sample.
No. It is telling you that when 100 people came, 30% of the time you find that these are the people who are buying laptop and antivirus together. The rest of the 70% of the time, these are the people who are just buying laptop. So is it like a big problem or a small problem? You can scale. You can, right? And this number is not very untrue, right? How many of you buy, when you have bought laptops and bought actually an antivirus from Jerry or Extra?
I'm the 70%.
But whoever bought it, those two things together, 70% of them also agreed to buy extended warranty. Can you read this whole association rule? So those 30% that bought laptop and an antivirus, out of those 30%, 70% of them, they also agreed to take extended warranty. Interesting rule, right? But very hard to pick just by seeing customers and not looking at this, creating those association rules. Okay. So the association rule can give you an output like this, which can be very useful. So whenever a person comes with antivirus and box and sell them extended warranty, they are highly likely to buy. Maybe they are defensive people. They are not relying on free antiviruses. So they are cautious people. They maybe not only buy. So if you can sell them extended warranty, they are highly likely to buy it. Okay. But this association rules have some more other advantages. Store design. I see that when you buy yogurt, you also buy vegetables. So put them together, store design. Because I know whenever people buy this product, the person buy that product as well, put them together, close to each other. Increase the exposure.
Like burger and fries.
Yeah, burger and fries, so put things that people expect to buy together, put them together close to each other, right? e-commerce site design, meaning that how many times have you seen Amazon when you bought, let's say, a camera, you start seeing ads for tripod stand?
For example, when you're buying for a laptop, you get the bag with it.
Something that you expect to buy, right? Like you stand, you're buying a camera, suddenly you see ads starting to appear on stands, right? Or they say people who bought this also bought this on the same page.
Mm-hmm.
How do they know? By using the association rules.
Mhm.
Okay, association rules.
And
I-
in media,
In medicine,
in medicine, I mean.
medicine meaning that if certain symptoms are coming together, it can help you diagnose.
Mm-hmm.
Two symptoms are
Diagnose mean product. Diagnose mean product.
Tashkhis.
Ah,
Yes.
okay. Ah,
Meaning that you have cough, you have certain fever, your eyes are red. All three, when they come together, it turned out to be a flu virus.
Mm-hmm.
Right? That's how people have not seen flu virus unless you take it to the lab, right?
Mm-hmm.
But people say when these three things come together, normally it is a case of flu,
Mm-hmm.
right? So I'm going to, okay, maybe this is like an association rule example of a particular algorithm again. Association is an approach, algorithms are needed to be used. So what they do is, this is the raw data in transaction 1, transaction 2, transaction 3. So first they start with how many times an item is repeated. You know the S and confidence, support and confidence. So you can see this one seems to be happening quite often.
Mm-hmm.
Then they use 2 pairs. How many times 1, 2, 1, 2, 1, 2 appear, right? And then how many times 3, 3, 3 of, so they keep going up.
Mm-hmm.
And then from there they drive rules. Oh, this one seems 2 and 4 seems to be appearing so many times again and again,
Mm-hmm.
right? So maybe we can create a rule on that. 2 and 4, 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 2 and 4. It seems 2 and 4 is always together,
Mm-hmm.
right? So it means that we can create an association rule between 2 and 4, right? Yes. Any question?
Thank you.
We are going to stop here. Artificial neural network. Next time, please bring your laptop.